soccer. I probably like, twisted ankle or right ankle. Broke my arm playing driveway basketball. That was pretty embarrassing. Sure, gosh, yeah. Did what? Did they explode? What do you mean? No, I was jumping off a trampoline to try to get a slam dunk. So, hey, we're going to finish 5.2.2 and then dive into the new lesson. So I do not guarantee that our homework is what I say it's going to be, but if we move quickly, this will be our homework. And remember the feedback on school.
I have a question for you.
Oh.
You solve it.
No.
You should learn.
You what? At 5.2.3, wait, 60. Hey, the board is wrong. The board, this is wrong. It's 49 to 53. That's a my mistake. Cross it out, write the right thing. I'm sorry. Then whatever we're taking notes in. 49 to 53. Today's Wednesday. Hey, I put Thursday's homework up there so you can work ahead if you want to. Okay, so work ahead if you want to. What? What? I'm not sure. We're going to finish your mastery on Friday, so I'll probably collect them on Friday. I'm not sure. You're asking if there's anybody? Some Friday if I need to, but this Friday, no, we don't have homework. Yeah, this Friday we don't. I try to avoid it. All right. Check out 535 with your team. We need to remember how to generate random numbers in the calculators. If you forget, ask your team. If you all forget, call me over. Now hold up. I need you guys to focus. I still feel like our focus is kind of scattered. So Janelle is going to babysit her nephew all day, 5 times. She had the idea that one way to entertain them is to walk to McBurger. I have no idea what they're for a kids meal for lunch each time. Now the kids meal comes packed randomly with one of 3 possible action figures. Janelle would like to know the probability that they get all 3 figures over the span of the 5 trips. So, give it a shot. If you are going 5 times and there are 3 action figures, how can you use the tech that you have to model the situation and find your answer? Talk as your team.
Yeah. Okay. Now, there we go.
Well, you see, I don't think I was there. She didn't get off. I'm trying to. But she didn't get off. I don't know about Billy. So yeah, we don't know. Wait, is this good now? Is it a 1, 2, 3? Was it pretty high chance? Alright, so we'll just say.
Who thinks they can coach me through the keystrokes? What we type on the calculator. How we do this. Rachel?
You hit math.
You hit math.
Then you use the right arrow to go to probability.
Go over to probability. We could use left arrow too.
And then you hit 5.
5 for which one? It says What's it say on Clyde?
Random.
Random integers is what it's abbreviating. You're generating random integers. What do you should type in that menu?
Well, for this one, we typed in 1 for the minimum, 3 for the maximum, and 5 for the, like,
How many?
How many?
Yeah. That's what n is. N is the number of trials. N often represents number when we use n as a variable. So, you should then on your screen show rand int parenthesis 1, 3, 5, parenthesis, and hit enter. The results are the action figures. Should not be error.
What the heck?
When you did something wrong. Tell them what they did wrong. And you still have those numbers there that you were trying to store. You need to clear this front menu. So hit clear like a couple times. Now. So, on your trials, did they get all 3 action figures? Why or why not? Explain how you know based off your tech. Your hand was up, or you brought it down? No? Okay. Izzy? 2, 3, 2, 1, 3 are the numbers you got generated, okay? We see all our numbers, 1, 2, and 3. They got a couple prizes a couple times, but that's okay. What happened at this group?
We got 2 and then quadruple
2, 3, 3, 3, 3. That's like you go there, you get a prize.
And then we got 1 quadruple.
Now imagine this. You go there, you get prize number 2. Then you go there, you get prize number 3. You're like, sweet, all I need is prize number 1. You go back, you get number 3. You go back, you get number 3. Really? You go back, you get number 3. Come on, this has to. Now, here's the human error. Your brain will tell you, man, I have to get number 1. Like, I keep getting number 3. The next one has to be a number 1.
You get a 2.
Is that true?
No. It can be
This
forever.
is the human error. Where if somebody tells you, hey, I flipped this coin 49 times and I got 49 heads, somebody's like, oh man, tails has to come up. I'm going to bet on tails. That's not true. The probability is still random, assuming the prizes they're choosing from are all randomized and equally distributed. So, simulate 5 trips if you guys did not follow the directions yet. See if after, then it says do it again. So, like, at least generate 4 sets of numbers, or they say 20 sets of 5 numbers. If you really care, you can keep hitting second entry, enter, second entry, enter. Let me pull up. So again, for it to type in exactly what you just had. Let me find a higher resolution. Oh, come on. No high resolution? Alright, this one's as good as we get then. We want to hit second and then the enter button. That copies exactly what you just had. Okay? That copies what you just had. Yeah, so this is some of the cool stuff it can do. So we are here. These. So, now, hold on. Hold up. Hold up. Give me your attention, please. How can we use this to determine the probability of getting all 3 in the week? Piper?
If you take how many times, we did it 10 times.
So they ran the trial 10 times. They generated 5 numbers 10 times.
Take how many times they got all 3 of them.
How many times did you get all 3?
7.
So they said the probability of getting all 3, they got 7 out of the 10 times they ran it. If we did what they told us to and ran it 20 times, we'd be out of 20. Rachel, what'd your group do?
We got 13 out of
13
20.
of their times.
That's so close to 7. Yeah, so close to
So this is 70%. Right? This, how do I get my percentage? Okay, we could find the decimal.
Or you could, or each, like 1 equals 5%.
Or multiply by 5. So 50 and 65%. Sure. What's up, Will?
Okay, so as you know, 70 was 70, 7 over 10 is 70%.
Mhm.
So then the equivalent to that would have been 14 over 20. And since each percent is 5, it's just 14 minus 5%, so to say, and that gives you 13, so 65%, because take out 5%.
Now, say that works with the 20, but be careful because here each trial is worth 10%.
Yeah, so you just have to
I have
Hello?
a question. Didn't you say that the more trials you do, the closer it's gonna get to the real?
Yeah, to what you actually think. We don't know exactly right now, and I don't want to overteach and confuse people. So this is how we're determining the experimental probability, because we're running an experiment, right? We're getting numbers generated. We didn't just collect data. We're running the experiment. This is experimental probability. We're just experimenting right now. We'll dig deeper into the law of large numbers as we get into this. Because remember, we spiral. We're going to keep doing probability all year long. It's one of the things kids like the most. So they're always like sad when we move on. CPM spirals. So we're going to keep revisiting the same stuff.
Like that picture of the repeating decimals I had.
Yeah.
Just
Yep.
spiraling.
All right. So Janelle thought that the chance of having 2 or more girls out of 3 children must be 50%. Wait, that's an odd statement. Let's back up. Janelle's aunt and uncle have children. 3 of them, to be precise. 2 of them are girls. Okay. 3 kids. 2 of them are girls. I mean, I was 2 boys, 1 girl, so poor sister of mine. And she was in between us. She's strong. So, Janelle, because of that, thinks the chances of having 2 or more girls out of 3 children must be 50%. That's a confusing sentence. So you can revisit that in a second, but hold on, I'm going to set this up. Janelle's brother thought the chance of having so many girls must be less than 50%.
Still 50-50.
Yeah, because it's either
Okay. So, a conjecture is a fancy word for prediction of what you think. So, make a conjecture. You guys all seem to have some strong opinions. Talk with your group. How can we figure out the probability of that happening? So, break it apart and dissect what they're really saying. Use your calculator. It says use the e-tool, but use your calculator. How many outcomes are there? Okay, and this is getting harder and harder to converse about in this day and age. How many genders are there? Quote unquote 2, right? Now we're getting into the gray area, but really when you look at biology, there's 2. I mean, you can go down to the DNA. I don't care what people identify as. That's your choice. DNA, XY chromosome. So if there's 2 choices, how can we use a number generator to make choices? Izzy? You have 1 and 2. And obviously, girls will be 1 because they're better. So, just use your number generator. 1 and 2. This is like binary. Or you could do 0 and 1 if you want. And it's how many times you want to try to do it. So, how many kids are we saying someone's going to have? 3 kids. So, each trial should be having 3 kids.
What happened?
Try it. We're not. So, hey guys, bring it back for a second. And I was going to direct this just to Will, but I need to direct it to everybody because this is a common misconception. Will's up here saying, well, boy, girl, 50-50. Like, I agree. But that's not what we're talking about. What we're talking about is the experimental. If I run an experiment, if somebody has 3 kids, quote unquote, each kid has a 50-50 chance of being boy, girl. But we're looking at the set of 3 kids. So you're looking for the results that you get. Say that your results come out 1, 1, 2. How I said it, girls being 1, that'd be girl, girl, boy. You do it again. If you get 1, 2, 1, that's still girl, boy, girl. You still have 2 girls. You're trying to run this a certain amount of times. Now notice, they say 1 is a girl, 0 is boy. It doesn't matter what other number you use for boy, as long as you have a other number there. Decide how many times you want to test this. Make your life easy. Sorry, our classroom set of calculators is with Mr. Hall. That's why we didn't work with group written. How many times could you run this to make your life easy? So then you'd have divided by 3 for your probability?
Okay, did 10 times. It is my results.
How many times?
16 girls, 15 guys.
What do you think would be easy to run? Yeah, we were talking about this the other day. I've never learned the algorithm. I like just playing with them, but I never wanted to because that like ruins it. I like goofing around with them, like just trying to figure it out. But once you know the algorithm, it's just following the process. That's like when someone teaches you how to long divide, and you just know how to do it, but you don't really like understand it.
I spent so much time.
How many trials would you say is enough?
We did 10.
I knew it would be a slow refocus because everyone's still happy. How many trials would you say is enough? They use this word that I hate.
10.
They say enough. Do enough. Enough. What? Give me enough pizza. Give me enough cookies, right? That's not. Who wants to talk about this? How many is enough? What did you guys choose? Why did you choose it? Rachel? What do you
We
think?
did 10 because like it seems like a good amount, and once you get too many, like there's 3 in each of them, so it just be a lot to calculate.
Okay, so they did 10. And what are we looking for here? What's the chance that we're looking for? Is it just having 2 girls?
No, 2 or more.
2 or more, right? So I heard Ian's group back there say, we got 1, 1, 1 3 times in a row. All of those situations were 3 girls, but they count for what we're looking for. Anytime you have 2 or more girls. Our answers here won't be the same because we're experimenting. How many of your trials out of 10? Did you run 10 yet? Did you guys run 10 yet? How many? What did you get? How many did you get out of 10 with 2 or more girls?
5 out of 10.
You guys got 7 out of 10? So they got 7 out of 10 back there. How many did you guys get?
5 out of 10.
5 out of 10?
We got 4 for getting 2 girls.
2 or more? Because some are, I mean,
Some are all girls.
and really we could say that, like, probability-wise, we'd run it the same way if we're talking about getting 2 or more boys. We'd just be looking at the complementary situation. What other results? We have a 4, a 5, and a 7.
We have a 5 out of 10.
You have 5 out of 10? Who's the group we haven't heard from yet? Yours?
Us, I think, because it took forever to get down.
You're good. Now wait, they said do enough trials. We've got 40% up to 70%. But what could we do to try to work smarter, not harder? Piper?
Couldn't we just
Combine your data. You did 10 trials, you did 10 trials, you did 10 trials, you did. This is what scientists do. You try it over here, I'm going to try it over there. There's actually, anyone watch Adam Ruins Everything?
Oh, yeah, I love that
So, an episode recently was talking about the replication epidemic that we're having in America in the scientific, like, world of studies. If something is valid, it should be replicatable, which means you can copy it. A lot of studies right now, sorry to burst the bubble, but I was surprised to hear this, the one on power posing, that it gives you endorphins, hasn't been replicated. No one has been able to get those results, aside from the people that did it initially.
Could they do it again and get the same results? Because the people that
Nobody else has been able to do it. Like somebody, like if I say eating green Jello makes you happy, you should be able to try the experiment and get the same results if mine was valid.
chocolate makes me.
So-
Give them like an extra like.
A lot. It's too long of an episode. So I was thinking about pulling up a clip. So there's a study, and we actually use this. And I do believe that it can help, but it's whether we can scientifically prove it. Power posing, standing in a way that makes you feel confident, like even like Wonder Woman or whatever else. They did a study, I forget who they was, that showed it increases your endorphins and increases whatever. It will make you more confident as you go into like a job interview, a test, or whatever. Which is great. Easy way to get endorphins. Some people do push-ups or whatever, like to get that rush of like feel good. Other people have tried the study, didn't get the same results. The only difference is they couldn't show an elevation or an increase. Doesn't mean that it didn't do anything, but they couldn't detect it. They couldn't prove it. So this study now is like, well, is it really valid since nobody else can get the same results? That's the question. And I'm not saying it's invalid. I'm just saying if it's really valid, you should be able to replicate it. So if you guys say 70%, we should be able to replicate it. If you guys say 40%, we should be able to replicate it. If we put all of these together, 5, 14, 7, 21 out of 40, that's right about 50%. Interesting. Yeah, so like 52, a little over. So I should have a squiggly equals in front of that because I approximated. So Sophia and her brother are trying to invent a game. Right? Actually, my brother-in-law just sent me a new game that we might try this Thanksgiving. I forget. Talk to me later. I'll pull it up.
Okay.
So Sophia challenges her brother. Take a game that involves 2 die, right? And if you want to make it awkward, get a giant one and then a little one and tell somebody to roll these. And make it fair. So you're going to roll 2 dice, 2 dice, whatever.
Yeah, 2 dice. Not 2 dice.
Talk about this with your team. How do we make a fair game? Using 2 dice.
That's heavy.
Home goods. $10. I've never been able to find another one. I want a second one.
There's a 1/2 chance. Yeah, there's a 1/2.
What is the probability your dice are even?
50%.
Is it?
Yeah, because 3 out of the 6 sides on a die are even. And then there's 2 die.
Okay.
And they can set
I
this
don't disagree with what you're saying.
6 pop.
I might disagree with that. Bilal?
I'm not sure if this is right or not, but since it's a 50% chance for one dice, if the probability to get both dice are even, you would have to split the 50% in half. I think. So
That makes
50% is one dice, then 25% would be both dice.
To get both of them even.
I agree. I think that's right.
No?
So we roll 2 dice, right? What do we do with 2 dice once we roll them? You do what? Okay, what do you do once you look at the numbers?
You follow the main
You break them down.
You follow the yellow brick road.
You add them up, right? Can you get a 1? If your game involves 2 dice, you can't get a 1.
Never mind. I think that's how you roll.
Continue talking about this now.
Homework for Bilal. Yeah, homework for Bilal. Today, homework for today. The Bilal of today.
Oh,
The result.
just tell me
So Izzy just asked, wait, is the question asking that the face show even or the result? We're talking about the result being even. So if we look at the what we want, we're going to have here all of these. Oh, that crap. I went off kilter. All of these, and this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah? No? No? 4?
Yeah, they're even. It's really good.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many total possibilities are there here? 36. 6 by 6, 36. So we do get 50%. Now, hold on, harder question. So probability that our sum is even. By the way, reminder, I go rogue from the textbook sometimes, so do not, if you're a textbook follower, I see people, sometimes I'm not discussing what's in the textbook. So like that, I don't even think that question's in the textbook, but I wanted to make sure we looked at this table. Now, what we want to answer is what's the probability, oh, come on, that both dice are even. Now, I'm kind of cheating by showing you this table. Both dice come up even. We're not talking about like what, I mean, they will add an even plus an even adds up to an even, but so does an odd plus an odd. Both dice even. if I use my table, how could I sort these? How could I figure this out? Zen?
Well, because it says die 1 and die 2, because we're not trying to find the total, we're trying to find the base of the die. You just look at every even number on the die.
So do I highlight this whole column?
No, you just the 2.
Ah.
Like this. 10, 8, 10, 12.
How many? Out of? What is that? I'll show you how to get there more easily. What's the probability when I roll a single die that it will come up even? So, to figure out the probability of the combined, what are we talking about? Is this our problem?
No. No, it's so good, brother.
We are thinking about even and then another even. So to write that out, we multiply the two situations. So what's the chance of getting an odd and an odd?
25%.
The same thing. Because half chance odd, half chance even. Now hold on, this gets weirder. What's the chances of getting an odd, then an even? Piper, because you raised your hand.
There are 4 possible things that could happen. You could get an odd and an even and an odd, an even and an even, or an odd and an odd. And
That's 4.
And if the other 2 chances are both 1/4 and are equivalent, and the other 2 chances are each can be 25%.
Love it. 4 possibilities. We can make a little table that shows this. If your dice are different, this will be easier to talk about. When we talk about odd even, that'd be one die odd, the other die even. When we talk about even odd, that doesn't mean trade places. That means literally this die, then instead of being odd, has to be even, and this die, instead of being even, has to come up odd. There are legitimately 4 different possibilities of the outcome: even, odd, 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 even, odd. Those are 2 different things. So be careful when we discuss these situations. We got like 12 minutes. Let's dive into our next lesson, please. 5, 2, 4. Nah, we got like 7, 8. We got a little bit. Wait. Are we? Wait. What did we just solve? Okay, so I'm a giant. No, yeah, today's Wednesday. Sorry, I keep confusing myself. Probably today's lessons are going to get spread to today, tomorrow. The homework's going to bump to next week because we're doing tests on Friday. Probably. Don't stress about getting homework done if we don't finish the lesson. I had a couple people stressing about last night's homework. We did not finish the lesson. Do not let yourself get stressed. So, in chapter 1, we met Chris and his older brother, or older sister, Rachel. Okay, yada, yada, yada. They've been washing dishes. She feels there's more than her fair share. She comes up with a new system. All right, here we go. She proposes that Rachel get 2 coins, and each day she and Rachel will take a coin and flip their coins at the same time. If the coins match, Chris washes the dishes. If they don't match, Rachel washes the dishes. Now realize, in the last 2 minutes, you would have had a night forgetting about the dice problem we just talked about. Right? Because this is a different lesson. So talk with your team. Is this a fair situation where Rachel has said, if the coins match, Chris washes the dishes, and if they don't match, Rachel washes. Yeah, it's a tongue twister. All right, talk about it.
It'd be a 50% that she doesn't have to. It'd be a 60. What's his name? Oh wait, they're still talking about dice.
That looks like one of those house trucks where they use trays.
That's exactly what it is. It's I forget exactly what these are called. It's essentially like a battleship, where the box in the table will be filled with the components from the boxes up and out. So, if we build a probability table to look at this, and this is why we did not do this on the dice, because we were heading to this in this lesson, we can look at in what situations do the coins match, what situations do they not. So, here, please build this on your notes. It's really quick to build, and it actually helps us immensely. This column shows getting a heads on the blue coin. This column shows getting a tails on the blue coin. This row shows getting a heads on the red coin. This row shows getting a tails on the red coin. Since we know each of these probabilities is a half, we know that the probabilities of each of these boxes is actually the same, because to get the probability in here, we do the product of their probabilities, and half times half we already talked about being 1/4. So each of these boxes we know is a probability of a fourth. What's the probability Rachel will wash dishes? 50%, because Rachel washes when the coins don't match. What is the probability? What's his name? Chris washes dishes. Sorry, 50%. So even though we're talking about match and don't match, they each have a 50% chance of happening.
I made it quicker. I didn't do that. As I said, there are two choices, match and don't match.
You can't just do that, because you have to look at how do we get to a match. How do we get, so say we were looking at dice and you look at match and not match. You can't just say there's two choices and match is one out of two. So for coins, because we know it's 50-50, that will be okay. But in any other situation where it's not, where it's not 50-50, you have to go through the process. Questions? So, we're trying to move quickly. Does one coin's outcome affect the other coin's outcome? No. Now, what would we call that? The one coin doesn't care about the other one. We talked about this with variables. Independent, but here we're not talking about variables, we're talking about situations, right? Flips. So these are independent probabilities or independent situations. Exactly. I'm trying to see what else we really need to cover.
Rock minus paper minus scissors.
Does it matter what the coins are? No. Exactly. The coin does not change probability. All right, we're good. We're good with that question. check out rock, paper, scissors. Game in your book, or I'll drag it onto this screen.
Rock. Let's play a hardy game of rock.
In case you don't know the rock, paper, scissors game. Yes, they literally. We don't know that you know how to play rock, paper, scissors.
You could have gone to them
I don't know.
school where they didn't use
I don't know. Right number.
So,
solving problems.
There's two problems.
White universe is a cheaper beat of rock.
covers it up. Yeah.
There's actually a storyline. Someone made a storyline about this.
Yeah, we know.
Well, if there's a lizard, there's a Spock also. All right, now, real quick, so I want to make sure we get this done while we still have class time. We are going to make a probability table for rock, paper, scissors. Okay? So, if you assume that your choice is random, what is the probability of each choice? A third, right? We have rock, paper, scissors. Rock, paper, scissors. Especially if you're color coding. I fill in all my blues first. Then I fill in my reds. See, you guys always say that I'm really loud.
Yeah. Well, you both are. Both really loud. She yelled in my ear once.
You should be Mr. McGuire then.
Yeah.
Now wait. There are 9 outcomes here. Someone has to have an advantage. Right? Because there's 9. Alex?
No, I just wanted to say there was a mistake on the first row.
Oh, what did I write wrong?
You put a P at the end. You put a P. SP at the end.
This?
No,
Ah, thank you. So I was getting corrected, not only because I wrote that wrong. Naya, I just said there has to be an advantage, and I'm guessing you disagree. That's what most people think, right? How do I split 9 with 2 people playing? Easy?
It's not that one person has one person can't have an advantage. It's just like
But why?
because like the way you think, like the way people think will determine their outcome,
Okay.
and the way other people think will determine their outcome.
Alana?
So, people like, nobody can have an advantage because they're not so like tic-tac-toe or something. The first person to go has the advantage because they're both going at the same time
Yeah?
and they both have like all of those advantages.
Okay. I don't want to ask this question, Rachel.
There's also like 3 of them, so like 9's divisible if I don't know if that's to do with it.
What's happening where I just circled?
They're tying.
They're tying. There are not 9 results where someone wins. There are only 6 results where somebody wins. So, paper covers rock, miraculously winning. Scissors cut paper, miraculously winning. And rock smashes scissors. Paper covers rock, rock smashes scissors, scissors cut paper. We have a 1/2 chance of winning, regardless of which person we are, because we see that each of those circles has a 1/9 chance. So it's not that we actually have a 1/2 chance of winning, but if somebody wins, we have a 1/2 chance. We'll pick this up tomorrow and actually talk about what is our chance of winning, because it's not a half. All right, have a great day, guys.
Wait, we still have homework, right?
Yeah, I mean, we should be able to do some, if not most of that homework. We only have a couple problems left. Yo.